Four matchsticks that are arranged in the shape of a cup. A coin is inside of this cup. The challenge is to move exactly 2 matchsticks so the coin is outside the cup, but the resulting shape must also be the same shape of the cup. So how do you do it? So here's one way to solve the problem. You take this matchstick and you slide it over to become the base of the cup. Then we'll take this matchstick and we will form the other side of the cup. So we now have the shape of the cup and the coin is outside of this upside down cup. So that's the standard way to solve this problem. But since we're talking about outside the box solutions, here's a creative way if you want to bend the rules a little bit. Let's take this matchstick and we will just gently push it over to the left. So we'll go ahead and push it over. It's going to touch the coin. And as it touches the coin, we just keep moving the coin. We're only moving this matchstick, but incidentally, it's going to move other things. So we then move over the other matchstick and the coin, and we form the other side of the cup. Now we're going to move another matchstick. So we take this matchstick and we just bring it around and we form the shape of the cup. So again, we have the shape of the cup and the coin is outside it if you allow this outside the box solution. Perhaps there are other ways to solve this puzzle too. The challenge is to make 4 equilateral triangles. Each side must be 1 full matchstick length. There is a hint in this puzzle, is that you are allowed to use glue to connect the matchsticks. So how can you do it? On first glance, this task seems impossible. If you have 6 matches, it would appear the most you can make is 2 triangles because each triangle will use 3 matches. So how are you supposed to make 4 equilateral triangles? The trick in this puzzle is not to think in 2 dimensions, but to think in 3 dimensions. Instead of just thinking about a flat triangle, let's imagine a 3-dimensional shape of a tetrahedron. So how is this going to help us solve the problem? Let's form the matches into a tetrahedron. So a tetrahedron will have exactly 6 edges, so we can use the 6 matchsticks to form a tetrahedron, and a tetrahedron will have 4 faces. So we've used the 6 matchsticks to make 4 equilateral triangles, which are the faces of the tetrahedron. And that's the incredible outside-the-box solution to this puzzle. Here we have 4 matchsticks that are arranged in the shape of a cross. The challenge is to move exactly 1 matchstick to make a square. Once again, this is a seemingly impossible puzzle. If you wanted to make the matchsticks to form the edges of a square, it would seem we would have to move 2 of the matchsticks to make a square arrangement. So how can we make a square? By moving just 1 matchstick. The trick is to think outside the box. Take this top matchstick and slightly move it upward. What happens when you do that? You end up creating a square between the 4 matches. Let's just zoom in so that we get a better illustration. The 4 matchsticks are forming a square, and all we did was move 1 matchstick upward. So this is the wonderful way to solve this problem. But since we're thinking outside the box, here's another creative solution. We also refer to squares in terms of square numbers. 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, and so on. And we do call the numbers 1, 4, 9, 16, 25 as squares. So let's say that 4 is the square that we are going to form. So we'll go ahead and take these 4 matchsticks. We will move exactly 1 matchstick, and we will form the number 4, which will be a square. And that's another possible answer. How many of these puzzles did you solve?